Did you know that telescopes are time machines?
Are you telling me that you built a time machine?
Because the universe is so vast, it takes the light from distant galaxies millions or even billions of years to reach us. So our telescopes observe these galaxies as they were millions or billions of years ago. ESO's Extremely Large Telescope, or ELT, which is currently being built, is no exception. The ELT is a time machine in more ways than one, because we just buried a time capsule in its foundations. Among the things buried is a book in which astronomers wrote what they think the ELT will discover in the future. Curious? Let's see what the universe has to say about this. Welcome to Chasing Starlight. I'm Suzanna Randall, an astronomer at the European Southern Observatory, ESO. And I'm super excited about the next big thing in astronomy, the ELT. At ESO, we already have the VLT, the Very Large Telescope. So when we thought about a name for the next, even bigger telescope, we came up with ELT, the Extremely Large Telescope. So I admit we astronomers are not particularly creative when it comes to naming our telescopes, but the names are descriptive. The ELT will indeed be extremely large and the world's biggest eye on the sky. It will have a main mirror diameter of 39 meters, which is 24 times my height. Because this is such a leap compared to current optical telescopes, it means that everywhere we look with the ELT, we'll find something new. Let's start our journey right here in our own solar system. From here, we're going to travel through space and through time. In our solar system, the distances we're talking about are already humongous by human standards. We're talking hundreds of billions of Ms. But in terms of time, because light travels so fast, we're still more or less in the present. The light from the sun takes around 8 minutes to reach us, while the light from the outer planets takes around a few hours. The ELT will be extremely useful to detect the faintest objects in our solar system, such as comets or asteroids. These are interesting not just because some of them may at some point hit us, but also because they're kind of like the fossils of the solar system. So they store the material that's left over from when the solar system was being born. And this means we can use them as time capsules to find out more about how the planets, including our own Earth, formed. Let's continue our journey and leave our solar system. The distance has now become so huge and unimaginable that there's just not enough Suzannas in the universe. And we're also continuing our journey back in time. Light from the nearest stars takes a few years to a few thousands of years to reach us. What's fascinating about these nearby stars is that we've discovered planets around many of them. We started discovering the first exoplanets in the 1990s, and since then we've found around 5,000. And the number will only go up with the ELT. What we haven't found yet is a second Earth. A small rocky planet that's in the habitable zone of its star at just the right distance for water to be liquid on the surface, that has a protective atmosphere, and water, who knows, maybe even life. Let's travel even further afield to the center of our galaxy, a whopping 26,000 light years away. Here lies a supermassive black hole, as we already saw in episode 1 of Chasing Starlight. A monster so gravitationally powerful that we can use it as a laboratory to push our understanding of physics to the limit. With the ELT, we'll be able to explore the immediate vicinity of the black hole in the center of our galaxy, where the gravitational pull is strongest. In order to really understand the black hole, we need to know its mass, which has already been measured, and also its spin, which so far we've not been able to determine accurately. With the ELT, we may be able to measure how fast the black hole rotates, and this would further our understanding of space-time itself. Let's accelerate our journey, because now I want to tell you about one of my favorite things the ELT will study. You see, the ELT is such a powerful time machine that it can look back billions of years, back to when the universe was only a few 100 million years old. Back then, the universe was cold, dark, and lifeless. It was only with the advent of the first stars and galaxies that things began to brighten a little. The ELT can look at these very faint objects back at the time of cosmic dawn and answer questions such as, what were the first stars like, and how did the first galaxies form? It's only by going back to the very beginning that we can understand where we truly came from. The ELT time capsule holds our best bets for what we think the ELT will discover. But, as ESO's ELT program scientist Michele Girasolo says, wherever we look, we're going to find something unexpected. And I have to say, I completely agree with Michele. And in fact, that is the beauty of science and of being an astronomer. We never know what we will find out there. If you enjoyed this video, don't forget to hit like and subscribe. And to be notified of future episodes of Chasing Starlight, activate the notification bell. If you have any questions, please put them in the comments below. For every episode, we will answer some of your questions.